Welcome to this explainer. If you're a focused learner looking to cut through the noise and truly understand how the world's most advanced technologies are actually built, well, you're absolutely in the right place. Today, our mission is to demystify responsible AI. We're going to take a close look at a fascinating and honestly sometimes uncomfortable reality: how our very own human flaws and biases can accidentally leak right into machine learning and artificial intelligence. Here's our roadmap for today. We'll start with 1, the human bias problem. Then 2, fairness in AI systems. 3, accountability and transparency. 4, safety against AI harm. 5, privacy and sensitive data. And finally, 6, the generative AI challenge. Let's dive right in. Section 1, the human bias problem. We have to start with a fundamental truth. AI is built by humans, and humans are flawed. I want to try a super quick mental exercise with you. Literally, close your eyes for a second and just picture a shoe. Got it? Okay, open them. Did you picture a sneaker? Maybe a high heel? Or a leather boot? The truth is, we might not even realize it, but each of us is naturally biased toward one specific type of shoe over all the others, entirely based on our own personal experiences. And that right there perfectly illustrates why data isn't just some neutral thing. You see, with traditional programming, people hand-code the solution to a problem, step by step. But with machine learning, computers learn the solution by finding patterns in vast amounts of data. Just because something is based on data doesn't automatically make it objective. If you're trying to teach a computer to recognize a shoe, and you only feed it the exact type of shoe you pictured, you've just exposed the computer to your own bias. Because of this, even with the absolute best of intentions, it's virtually impossible to completely separate our humanity from the tech we build. These human biases sneak into AI in 3 distinct ways: interaction bias, latent bias, and selection bias. Let's break these down. First up, interaction bias. This happens dynamically. Imagine a game where people are asked to draw shoes for a computer to recognize. If the vast majority of users draw a standard sneaker, the system learns from those specific user interactions. Over time, as more people interact with it, the computer might completely fail to recognize a high heel or a boot as a shoe at all. It just ignores them. Then we have latent bias. This one is perfectly demonstrated when we look at historical data. Say you're training an algorithm to recognize what a physicist looks like, and you use historical pictures of past physicists. Because the field historically favored men, your algorithm is going to end up with a latent bias. It unintentionally skews its results to identify men as physicists, potentially ignoring women altogether. You can easily see how this becomes a massive problem if that AI is used to screen resumes for a real-world job opening. Finally, selection bias. This happens at the very beginning of the process. If you're training a model to recognize faces, and you just grab images from the internet or your own photo library, you have to ask yourself, are you selecting photos that actually represent everyone? If your training data fails to represent a diverse array of ages, ethnicities, and facial structures, the resulting AI will be fundamentally skewed from day one. Moving on to Section 2, fairness in AI systems. Once we acknowledge that human bias exists, we have to actively design for fairness. Fairness is all about identifying, measuring, and mitigating these algorithmic biases. We absolutely have to ensure that algorithmic decision-making doesn't result in disparate, unfair outcomes related to sensitive characteristics. We're talking race, income, sexual orientation, gender. Think back to that hiring algorithm. We must guarantee it doesn't systematically discriminate against applicants just because their names are historically associated with a particular gender or ethnicity. A really fantastic, concrete, real-world application of this principle is the Monk's skin tone scale. This isn't just some abstract idea. It's a tool actively used to improve how diverse skin tones are accurately represented across massive platforms like Google Search and Google Photos. It ensures that technology actually works fairly for everyone. Section 3, accountability and transparency. Fairness is the goal, but we have to ask, who's responsible when an AI system makes a decision? Accountability means literally taking ownership of the effects of an AI system. It's about pulling back the curtain. We have to share information about the system's behavior and the organizational processes behind it. If we don't document exactly how datasets were created, trained, and evaluated, end users can't possibly trust the outputs. It's that simple. In practice, we achieve this through tools like model cards and data cards, which basically keep a detailed record of how the AI was built. But beyond just documentation, we need 2 key things. First, interpretability. meaning developers can actually identify why a model made a specific prediction. And second, explainability, which means translating those complex decisions so everyday users can understand and trust them. Section 4. Safety against AI harm. It's not enough for an AI to be fair and transparent. It absolutely must be safe. Safety involves incredibly strict design and operational techniques. The whole goal here is to avoid and contain actions that could cause harm, whether that harm is intentional by a bad actor or entirely accidental. We have to ask, is this system robust enough to operate safely if it gets pushed to its absolute limits? Will it remain reliable and stable if it faces a severe security breach or targeted attack? One of the absolute best ways to do this is through adversarial testing. It's exactly what it sounds like, the practice of deliberately trying to break your own application. Organizations use ethical hackers, like Google's dedicated AI Red Team, for example, to aggressively attack the system with malicious or harmful input. They learn its vulnerabilities so they can patch them long before the product ever reaches the public. Section 5. Privacy and sensitive data. Machine learning requires immense amounts of data, which means we have to fiercely protect that information. Privacy and responsible AI goes way beyond just checking a box for legal compliance. It's about deeply considering the real-world implications of using sensitive data. We have to respect social norms and what individuals actually expect. You have to anticipate what a machine learning model might inadvertently remember about, say, the medical records or private messages it trained on, and ensure users always have control over their own data. To actually do this, we use some pretty brilliant safeguards, things like randomized response, which lets us collect data without tying it to your specific identity, and federated learning, which allows an AI to learn from data directly on your phone without your private information ever leaving the device. These are critical steps to prevent these massive models from leaking sensitive user data. Which brings us to Section 6, the Generative AI Challenge. We've laid out the core safeguards, but this new frontier is pushing them to their limits. With the advent of large generative AI models, the rules of the game have completely shifted. We're facing breathtaking new challenges simply because the capabilities and outputs of these models are incredibly open-ended. Because generative AI can be used in thousands of unpredictable downstream applications, it requires incredibly strict policies, advanced safety guidance, and robust prompt engineering to keep it aligned with responsible practices. To truly build AI responsibly at scale, we absolutely cannot treat these concepts as an afterthought. Assessing AI for fairness, accountability, safety, and privacy must be woven into every single step of a product's lifecycle. From the very first design phase, right through to deployment and ongoing maintenance, these checks are what actually ensure the development of safe, equitable, and reliable products for everyone. Which leaves us with this final provocative thought to chew on. We know human bias exists. We know the frameworks to fight it. But as generative AI continues to evolve at breakneck speed, how do we continuously and reliably enforce these rules when the technology's potential outputs are virtually limitless? It is arguably the most important question developers are facing today. Thanks so much for joining me on this explainer. Keep asking the hard questions and keep learning.